Hello everyone. In today's video, we are going to discuss about decision tree algorithm. Introduction. Decision tree is one of the most powerful and popular algorithm. Decision tree algorithm falls under the category of supervised learning algorithms. It works for both continuous as well as categorical output variables. Used Python packages. sklearn. In Python, sklearn is a machine learning package which includes a lot of ML algorithms. Here, we are using some of its modules like train, test, split, decision tree classifier, and accuracy score. NumPy. It is a numeric Python module which provides fast maths functions for calculations. It is used to read data in NumPy arrays and for manipulation purpose. Pandas. Used to read and write different files. Data manipulation can be done easily with data frames. Installation of packages. In Python, sklearn is the package which contains all the required packages to implement machine learning algorithm. You can install the sklearn package by following the commands given below using pip. Pip install -u scikit-learn. Before using the above command, make sure you have scipy and numpy packages installed. If you don't have pip, you can install it using python get-pip.py. Using conda install scikit-learn. Now let us look into assumptions. At the beginning, we consider the whole training set as the root. Attributes are assumed to be categorical for information gain and for Gini index. Attributes are assumed to be continuous. On the basis of attribute values, records are distributed recursively. We use statistical methods for ordering attributes as root or internal node. Pseudocode. First, the best attribute and place it on the root node of the tree. Now, split the training set of the dataset into subsets. While making the subset, make sure that each subset of the training dataset should have the same value for an attribute. Find leaf nodes in all branches by repeating step 1 and 2 on each subset. While implementing the decision tree, we will go through the following two phases. First is the building phase. Pre-process the dataset. Split the dataset from train and test using Python sklearn package. Train the classifier. Second is the operational phase. Make predictions and calculate the accuracy. Data import. To import and manipulate the data, we are using the pandas package provided in Python. Here, we are using a URL which is directly fetching the dataset from the UCI site. No need to download the dataset. When you try to run this code on your system, make sure the system should have an active internet connection. As the dataset is separated by comma, so we have to pass the sep parameters value as comma. Another thing in notice is that the dataset doesn't contain the header, so we will pass the header parameters value as none. If we will not pass the header parameter, then it will consider the first line of the dataset as the header. Data slicing. Before training the model, we have to split the dataset into the training and testing dataset. To split the dataset for training and testing, we are using the sklearn module train test split. First of all, we have to separate the target variable from the attributes in the dataset. Given are the lines from the code which separate the dataset. The variable x contains the attributes while the variable y contains the target variable of the dataset. Next step is to split the dataset for training and testing purpose. The given line split the dataset for training and testing. As we are splitting the dataset in a ratio of 70:30 between training and testing, so we are passing the test size parameters value as 0.3. Random state variable is a pseudo-random number generator state used for random sampling. Terms used in the code. Gini index and information gain, both of these methods are used to select from the n attributes of the dataset which attribute would be placed at the root node or the internal node. Gini index. Gini index is a metric to measure how often a randomly chosen element would be incorrectly identified. It means an attribute with lower Gini index should be preferred. sklearn supports Gini criteria for Gini index and by default it takes Gini value. Entropy. Entropy is the measure of uncertainty of a random variable. It characterizes the impurity of an arbitrary collection of examples. The higher the entropy, the more the information content. Information gain. The entropy typically changes when we use a node in a decision tree to partition the training instances into smaller subsets. Information gain is a measure of this change in entropy. sklearn supports entropy criteria for information gain, and if we want to use information gain method in sklearn, then we have to mention it explicitly. Accuracy score. Accuracy score is used to calculate the accuracy of the trained classifier. Confusion matrix. Confusion matrix is used to understand the trained classifier behavior over the test dataset or validate dataset. This is the code that is used to implement the decision tree algorithm in Python. This is the result that is obtained while using the Gini index. And this is the result obtained by using entropy. In conclusion, the decision tree algorithm is a powerful tool for effective decision making. By understanding its mechanics and applications, users can leverage its capabilities to achieve their goals and make informed decisions. Thank you.